Sections 4.1 and 4.2. In 4.1, we're going to talk quickly about angles, and then in 4.2, we will talk about the trigonometric functions. Okay, so I'm sure if I asked you, hey, what's an angle? You have a pretty good idea what an angle is. The mathematical definition is an angle is generated by rotating a ray about its fixed endpoint from an initial position to a terminal position. All right, a lot of fancy words for saying there's an endpoint. We draw a ray, and then we rotate that ray, like so maybe. And then this would be called the angle, and we would measure that angle somehow. We've used degrees up to this point to measure angles. All right, an angle is said to be in standard position if its initial side is on the positive side of the x-axis. So in other words, we typically assume that this is the initial side and we don't draw it, and then we only draw the terminal side and we draw our angle like so. Angles measured counterclockwise, like this one, are considered positive, and angles measured counterclockwise, like I could write that angle that way, would be considered negative. And then coterminal angles. Two angles are coterminal if they share an initial and terminal positions. So what I just drew here were coterminal angles. I could call this angle this positive amount of rotation, or I could call it this negative amount of rotation, and we consider those coterminal. And those will be important for us. All right, so it says, graph the angles in standard position. So 225 degrees. So we start here, positive, so we're going this way. So this would be 90, this would be 180, this would be 270, so we've gone too far. 225 is in between. So 225 might look something like that. Then it says negative 45 degrees. So negative means we start here and we rotate in this direction. Negative 45, that's halfway between 45 and 90. So negative 45 degrees would look like so. Let's see, 120. Do I have more colors here? Probably not. 120 degrees. This would be 90, 180. So it's in between, but it's closer to 90. So 120 degrees might look something like that. And then finally 180. Well, 180 is easy. 180 is half of a complete rotation. Okay, determine two coterminal angles, one positive and one negative. So think of what we have here. We have 135 degrees. That looks something like this. A coterminal angle that would be negative would be this one. To get that, think about taking one complete loop around, that would be negative 360, and then going back the 135. So one coterminal angle is 135 degrees minus 360 degrees. So grabbing my calculator, 135 minus 360 is negative 225 degrees. So there's the negative one. The positive one, start here, go all the way around, that's 360 degrees, and then do another 135. So another correct answer is 135 degrees plus 360 degrees. Oh, I don't need a calculator for that. That's 495 degrees. Okay, so finding coterminal angles is pretty easy. You add 360 or subtract 360. Or you could add 720 and subtract 720. Why 720? Because 720 would be two complete rotations. Now, generally, we only do the 360, but you could do more if you want. So this one would be negative 65 plus 360 degrees. and negative 65 degrees minus 360 degrees. Grabbing my calculator, negative 65 plus 360 is 295 degrees, and negative 65 minus 360 is negative 425 degrees. Okay, so finding coterminal angles, not a big challenge. Coterminal angles will be something very, very important to us here in a couple of sections. Not so much today. All right, so now on to section 4.2. We're going to define the trigonometric functions, and these will be critical to us. We will be using the trigonometric functions for the entire rest of the semester. The rest of the semester, we're going to be doing trigonometry. So definition is, let xy be any point, except the origin, on the terminal side of an array. So you can see I got xy here on the terminal side of an array. The angle theta is in standard position, always in standard position. Let r be the positive distance between the origin and the given point. So r is that distance. So we've got x, we've got y, we've got r. Then here are our 6 trigonometric functions. We have sine of theta. Sine of theta is y divided by r. Cosine of theta is the x value divided by r. And tangent theta is y over x. And you can see how to state each of these: sine, cosine, tangent. Then we have what are known as the reciprocal functions. Cosecant, abbreviated CSC. Cosecant theta is r over y. So you notice we just flipped the sine over. So it's the same as 1 over sine theta. Then we have secant theta. Secant theta is the reciprocal of cosine. It's r over x. It's 1 over cosine. And finally, cotangent theta is x over y. It's the reciprocal of tangent. So you really, really, really need to memorize those. We will use those every day from now to the end of the semester. You need to know those. Once you know those, you need to know how to pair these. And it's a little unfortunate that they don't go together, but they don't. It might have been easier if cosine went with cosecant, but it doesn't. So you just need to remember that sine goes with cosecant. So if you know the sine, to get the cosecant, you just flip it over. Cosine goes with the secant. So if you know the cosine, to get secant, flip it over. And tangent and cotangent, those two are easy. Nobody ever has trouble remembering those. Okay. Determine the values of the trigonometric functions of the angle in standard position whose terminal side lies on the given point. All right, so I'm going to draw a picture, although we don't really need it, but it helps the first time maybe. We've got the point 5, 12. That's way up here. 5, 12. What we need to know is our r value. So we know that x is 5 and y is 12. So to find r, this is a right triangle, so we can use our old friend, the Pythagorean theorem. 5 squared plus 12 squared is r squared. That's 25 plus 144 is r squared. So r squared is 169, which means r turns out to be a nice number this time. R is 13. R normally, in most cases, will probably not be an integer. It'll probably be an irrational number, square root of something else. In this case, I picked one to make it come out nice. All right, so here's my answers. Sine theta. Now notice when you write sine or any of these trigonometric functions, you always need to put an angle there. Without an angle, you're not correct. It would kind of be like writing square root equals 10. That really doesn't make any sense. I mean, we know what it means. We really mean square root of 100 equals 10, but it needs a number. It needs something there. Square root needs something. The trig functions need something. They always need an angle. All right, so sine theta is y over r, and that's 12 over 13. Cosine theta is x over r, which is 5 over 13. X is 5. cotangent theta is y over x, which is 12 over 5. Now, I do not expect you to write y over r, x over r, y over x every time. I'm writing them now just because if we write them enough, we will memorize them by accident without having to try. So I'm just getting in the habit of writing them now to help you memorize them. All right, then to find the other ones, cosecant theta, I flip this one over. It's 13 over 12. Secant theta, I flip this one over. It's 13 over 5. And the last one, cotangent theta, I flip that over. 5 over 12. All right, next problem. I'm not going to draw a picture this time. We really don't need a picture. What we need to know is that x is 840, y is 130, and then we need to find r. To find r, we use the Pythagorean theorem. R squared is always going to be x squared plus y squared, which is exactly what we did in the previous problem. So r squared is 840 squared plus 130 squared. Grabbing my calculator, 840 squared plus 130 squared, r squared is 722,500. And it does once again turn out to be a nice, relatively nice number. Oh, you can't see what I'm writing there. Sorry, let me move my camera a little bit. 850. Again, in most cases, these will not come out to be particularly nice numbers. That's okay, we'll deal with it. All right, so the answers are sine theta. Again, I'm going to write this, although I don't necessarily expect you to write it every time. But if you do keep writing them over and over again, you'll memorize it. Sine theta is y over r. That's 130 over 850. I'm going to write that as 13 over 85. I can reduce top and bottom by 10. If you did not reduce top and bottom by 10, I wouldn't really care. It would still be correct. Cosine theta is x over r. That's 840 over 850. Again, I'm going to reduce by 10. Call it 84 over 85. And tangent theta being y over x. That's 130 over 840. I'm going to write it as 13 over 84. Again, once we have those three, we kind of get the other three for free. We just got to remember who goes with what. Cosecant theta is 85/13. Secant theta is 85 over 84. And cotangent theta is 84/13. All right, going to pause the video here, end part 1, and we'll continue on. We'll do another example or two for part 2.